Alright, so we are on question 4 of the November 2018 South African CAP Syllabus Matric Mathematics Exam, paper 2. So question 4 is a question on analytical geometry, specifically focusing on circles, as you can see. Right, let's read it. So in the diagram, the equation of the circle with center F is that. So they give us the equation of this circle. And the point is, they give us a point on circle with center F, another circle with center G, and we don't have the coordinates for G. In the fourth quadrant, okay, so we know it's in the fourth quadrant, touches the circle F at H, such as FH to HG. Okay, maybe we should just draw that in quickly. So FH to HG. So they tell us that this is a ratio of 1 to 2, right? And this obviously forms a straight line. So we'll have that to look at later. Let's keep that in for later. FH, HG, 1 to 2. Let's just write that in so we have it. Alright, the point J lies in the first quadrant, such that HJ is a common tangent to both. So this is a tangent to both circles, this line. And JK is a tangent to the larger circle, so this is a tangent to the larger circle. Good. Let's see the questions. So maybe let's just see the equation of a circle in general. So the general formula for equation of a circle is x minus a squared plus y minus b squared equals r squared, where a and b, so the center of the circle has coordinates a, b, if this is the form, and r is the radius of the circle. Ooh, that's not radius. Radius of the circle. Okay, so that's some information we know about circles. Now let's see, what does question 4.1 have for us? So 4.1, write down the coordinates of f. So f is the center of this circle, right? And we have that equation. Let me just write that down. So that equation is x minus 3 squared plus y minus 1 squared equals r squared. Okay, so the center of the circle we just read off the values of a and b, right? So the point F, which is the center, just has the values of 3 and 1. Great. That is the answer to question 4.1. Nice, let's get into question 4.2. 4.2. Calculate the length of Fs. Okay, so we can calculate this length, pretty straightforward. We just use our distance equation. And have a look at the previous video where we discussed where that distance equation comes from. In essence, it's just Pythagoras that we use to find that. Maybe I can just show it again quickly. So if let's draw it like this. So if we want Fs, right, let me draw that again. So if we want Fs, we can say, well, we can just use Pythagoras to find that, right? We can just say, draw a straight line down, connect it here, and then we have a little right angled triangle, right? Just try and draw a right angle there. Right angled triangle, so we've got the difference between the x value squared plus the difference between the y value squared equals the hypotenuse squared. So that's where the formula comes from. Now let's just apply the formula. So Fs squared, or Fs by itself, is the square root then of difference between the x value squared. So this x value is 3, that one is 6, so the difference between them is 3. So I'll just write the whole thing. So 6 minus 3 squared plus the difference between the y value squared. So the y value there is 5 minus this y value, which is 1 squared. So Fs equals, the 6 minus 3 squared is 9, 5 minus 1 squared is 4 squared is 16. So we've got the square root of 25, which is just 5. So Fs has the length of 5, or a distance of 5. Okay, now we get to question 4.3. 4.3. Write down the length of HG. Okay, so what we need to know here is, we know that the ratio of FH to HG is 1 to 2. So if we know the distance of FH, we can find HG, right? So let's have a look at this. So Fs, we know what Fs is. We know that's 5. And Fs is a radius, right? But Fh is also a radius, so that's also 5. Okay, so if we found that this is 5, and we know therefore this is 5. So if this ratio is 1 to 2, then this must be 10, right? Let's just write that down in mathematical terms. So we're going to say we need to find hg, but hg equals 2 times fh. 2 times fh. Right, but fh is equal to fs. What is the reason for that? Both are radii. Okay, so then we can again say hg is then 2 times fs, because fh and fs are the same. That gives us hg equals 2 times, and we found fs was 5. So then we can just say hg equals 10. So hg equals 10. Okay, and I think it would be fine if you just wrote hg equals 2 times 5. I think that would be fine. Alright, that was question 4.3. Just knowing that using the fact that they gave us the ratio of 1 to 2, then we can find that. Right, the next question, 4.4. Yeah, let's do that at the bottom here. 4.4. 4.4. Okay, give a reason why JH is equal to JK. So let's just highlight those. JH equals JK. Why are they the same length? So why are they equal to each other? Right, so there's just a reason that we have to know for this. The reason is, and I'll just write it down. The reason is tangents from a common point. Tangents from a common point. Common point. Okay, so in essence, let me just draw a circle to show. If we've got any circle and we've got a tangent, well, actually, let's draw a bit better. We have a circle too, why not use it? So we've got a circle, and we draw a tangent to the circle, and we draw another tangent from this point. So from the same point, we draw another tangent. So if we do that, these two lines will always be the same length. And we can see it looks like they're the same length. Let's try from a different point. Let's try tangents from this point. So from this point, if we draw a tangent, there, and then from this same point, we draw another tangent there, we can see they are again the same length. So that's just a rule. Tangents from the same point will have the same distance. Great. 1 mark. Nice. Now 4.5. 4.5. Okay, so let's start that. Where shall we start that? Start that over here. 4.5. Oopsie. Get rid of the straight line tool. 4.5. 4.5. So determine the distance fj. So we need to find fj if it is given that jk is 20. So if they tell us this is 20, then we have to find this distance, fj. Fj. Okay, so how are we going to do that? Well, I think the best way to do that is to recognize this. That if we use this triangle here, right, if we use that triangle there, now this is a right angled triangle. Why? Because it's a radius and a tangent that meet, which makes a 90-degree triangle. Then we use the fact that this distance and this distance are equal, so we can say that's 20. And then we can say, well, we can just use Pythagoras to solve for fj. So that's exactly what we'll do. So first we need to say, let's first say that jh equals 20. Okay, so jh equals jk equals 20, and that was given. That was given. So that's our reason. We were told they're the same. Okay. Now, next thing we can do is we can say angle FHJ is 90 degrees. So angle FHJ equals 90 degrees, and the reason for that is a radius and a tangent are perpendicular to each other. Radius is perpendicular to a tangent. Great, so now that we know this, now we're allowed to use Pythagoras, right? So now we can say fj, or let's just say fj squared equals fh squared plus, so fh squared plus jh squared, or hj squared plus jh squared. Okay, fj squared we don't know, we're trying to figure that out. So fh squared, fh we found was 5, right? Fs and fh are the same thing. So fh is 5, that's 5 squared. And jh we know is 20, so that's 20 squared. Great, now we just solve. So fj squared equals 5 squared is 25 plus 400 is 425. So fj is the square root of 425. And this should be fine, but I would suggest let's simplify this into, I believe that's 5 root 17. That's fine, or you could do round off to a certain number of decimal places depending on what they say in the front of the exam. So that'll usually be 3 significant figures that you can round this off to if you write it in decimal notation. I prefer just the simplified surd form. Alright, so that's the distance fj. So what did we use for that? We used the idea that they gave us these two lengths are equal. So we could use that to have this length. And then the idea that a radius and a tangent are perpendicular to each other, making a 90-degree triangle where we can use Pythagoras to solve for fj. Right, now that's 4.5.1. Now let's look at the next one, 4.5.2. Okay, for 1 mark, let's do that over here. 4.5.2. So what does this say? Okay, determine the equation of circle with center G, so the equation of the big circle, in terms of m and n. That's nice, so we don't need m and n, in the form of this. Okay, so what we need, let me just move this slightly out of the way here. Let's do it over there, so we've got slightly more space. So we know it's going to be x minus the x value of the center, which is m. So x minus m squared plus y minus n squared for the y values equals, and now what is the radius of the big circle? Well, we know the radius of the small circle is 5, so the radius of the big circle, we already know that that's 10. So 10 squared is 100. Alright, so that's it for 1 mark. Nice. Then, question 4.5.3. Let me move this out of the way so we can work here. Let's move that over there, and then do 4.5.3 over here. So 4.5.3. Okay, the coordinates of G. Now we need to find M and N. If it is given that JK has the equation of x equals 22. Okay, so this has the equation x equals 22, this line. Right. Okay, so if we know it's x equals 22, we know it's a vertical line, right? The gradient is infinite or not or undefined in essence. So we know it's a vertical line because the equation is x equals 22, which means from here, if we go straight to the side, we can find, we can know this distance. Actually, let me just draw a straight line in there. So straight from this point of contact here, we draw a horizontal line there. We know this distance is the radius. We know this distance is 10, right? And we know a tangent and a radius are perpendicular, so this is just a flat horizontal line. So we can know this value of k has an x value of 22. Ooh, let me rewrite that. X value of 22. We don't know the y value, but that's fine. So if the x value is 22 here and this distance is 10, what is that x value? What is the value of m? Well, it's 10 less, 10 to the left of 22, right? So we can just say that straight away. We can say m is 22 minus 10. So m equals 12. All right. Now we need to find n. Now, n looks like it's going to be a little bit more complicated to find, but also not too bad, right? So what we can do is we can use this straight line here, FG. We can use that, right? So we know that they're collinear, so these are on the same line, so that's one straight line, like we said. And now we know this distance FG is 15, right? 5 plus 10. Let's start with that. So we know FG equals 15. Okay, so if that's 15, and we know the coordinates of F, we know the x value of G, we can just use that to solve. So I think that's the shortest method and the quickest method to solve here. So let's say the formula that we want to use, we want to say Fg squared is equal to, and then the x coordinates of F. So F has x coordinates of 3. We're going to have 3 minus, and this coordinates here, I'm actually just going to do it the other way around. I'm going to start with G. So m we know is 12. So 12 minus the x coordinates of f squared plus now the difference between the y values. So the y value of g is n minus, what's the y value of f? 1 squared. Good. And then we can just solve for n. I hope this makes sense. Let me know if I didn't talk clearly enough or you got confused about what we're doing here. We're in essence just saying we're using the distance formula for fg. We already know the value for m, so we just plug it in. Okay, so fg squared, and we know fg squared, right? We know this distance, fg is 15. We found that there. So we have 15 squared equals 12 minus 3. Let me actually do 15 squared, we know is 225. Right, 225. 12 minus 3 is 9, 9 squared is 81. Plus n minus 1 squared. So in this case, you could multiply out the brackets. I'm just going to use this whole one. So I'm going to say 225 minus 81 will give us 144. Is that right? 144, I believe. And equals n minus 1 squared. So then we take the square root of both sides. So plus or minus 12 equals n minus 1. So then we get either 12 plus 1 for n, or, not on, or we get negative 12 plus 1. Negative 12 plus 1 equals n. So we get 12 plus 1, 13 equals n, or we get negative 12 plus 1 is negative 11 equals n. Now, let's see, which one of those will it be? Do you think this n value is 13 or negative 11? Right, it has to be negative 11, right? It's negative y value. It's in the fourth quadrant, so you know the y value has to be negative. So this is our answer for n. That one will not work because that's not going to be in the fourth quadrant. So then we can write down the coordinates of g are the x value is 12, or m value is 12, and n is negative 11. Great. There are many other ways we could use to find the coordinates of g. Let me know which one you chose. One of my other instincts was to find the coordinates of h first, and then use the 1 to 3 ratio to find the coordinates of g. But finding the coordinates of h would also be a bit of work. Right, but let me know if you chose that method or maybe any other method. And then I'll see you again for question 5.